Good evening, everyone, and thank you for joining us for tonight's vBrownBag. I'm your host, Tom Green, and we're going to be talking about NSX and CNA. That's an awesome topic with a lot to talk about, so we're going to jump in. But first, we have some housekeeping. We like to keep this interactive. We like to talk a lot. So if you can use Twitter and use hashtag vBrownBag, we'll get your questions asked on the live show. And we also monitor that sort of recording. So if there's any questions afterwards, we'll still monitor that and we'll get someone to reach out and help you. We have many different regional shows. So while this is the US show, it's not the only show. If you go to vBrownBag.com/brownbags, you can see the schedule and sign up. So as I said, I'm Tom Green, and we're joined tonight by co-host Louis. Louis, will you introduce yourself?
Good evening. My name is Louis Ayuso. I am a systems engineer as well for VMware.
All right, great. Thanks, Louis, and glad to have you. And finally, Niran, you're the man of the hour. Please introduce yourself, and I'll get control over to you.
Thanks, Tom. Hey guys, Niran Even-Chen here. I am also system engineer at VMware. Let me just show my screen. Can you guys see my screen here? Good?
Yep, looks great.
Cool. So yeah, my name is Niran Even-Chen, a system engineer. What I do is I focus right now on NSX, specifically NSX-T, and integration with cloud native applications, CNA, that someone asked me today. So cloud native applications. And I meet with lots of customers implementing NSX, or actually working with them on the requirements for NSX with integration with Kubernetes or Pivotal Cloud Foundry, what's called today PAS. And what I'm going to do today is I'm going to go through like just maybe very small amount of slides and we'll dive right into the demos, because I think the best way to explain kind of the benefits of the integration and the product is through, well, click through showing you exactly what's going on. My session called CNA and NSX, like peanut butter and jelly, not for nothing. I believe this is the best networking and security solution today for cloud native application platforms, and you'll see throughout my session why. If you have any questions, feel free to, as Tom said, and Tom will break in and will ask me the questions. So just a few words about VMware and Pivotal and our solution in the market for cloud native applications, our joint solutions. So what you see is what, well, this is a term that's not being used anymore too much, but what we call developer-ready infrastructure, where on the green box in the bottom, what you see is VMware, where VMware lives mostly, which is where the platform operator lives. The platform operator is kind of a new role we see within many of our enterprise customers, where this is not IT, not your traditional vSphere guy or anything like that. These guys are usually responsible to provide the logical platforms like Kubernetes or PCF to the developers. So they work with IT, but they really are responsible to provide the abilities for the developer to have the most seamless experience when they develop their applications. And as I said, the green box is kind of where VMware lives and breathes. You can see we have vSphere, obviously, NSX is going to talk about. We got vSAN. On the right side, you can see we got a plethora of operational tools that VMware provides for our customers that answer on different requirements of the stack. I'm not going to go through all of them. And on the top, you see in the blue box, that's where the developer lives basically, and the developers, they don't care about infrastructure. All they want is this seamless as much as possible experience when they're working with developing their applications, and the underlying infrastructure should accommodate. Just like the carburetor in a car, you don't see it, you don't touch it, but it does its job. That's kind of the analogy I usually provide for the infrastructure in the bottom. And that the developer interaction is a lot of what Pivotal is very experienced with. And if you can see kind of where those two boxes meet is the solutions that we currently have in the market is Pivotal Cloud Foundry, or what it's called today PAS. PCF kind of was elevated into umbrella marketing term for PAS, and PKS, which is Pivotal Container Service, which is Kubernetes as a service. And the demos I'm going to do today will show the integration with both. I'm also going to show you guys kind of the robustness of the API of NSX, how easily and how good it is on automation. So there's different levels of abstractions when it comes to cloud native applications that our customers, looking for. On the left, what you can see is some customers that are looking only to run, containers. Where containers, when talk about cloud native applications, they're kind of became synonymous with cloud native, right? Because that's kind of a very good vehicle to use when you want to do continuous integration, continuous development. And some customers are looking for just running containers on container runtime. In the middle, those are more sophisticated customers that are looking to orchestrate multiple containers, more in scale. They're looking to schedule those containers and to have some primitives to have some routing, logs, and metrics for that. And on the right side, those are kind of the customers that are looking to have as less interaction with the infrastructure underneath as possible, so that the solution does everything for them. So whether it's to build the images, the container images, provides a lot of services around the containers and the management of them. And when we look at complexity versus control, it's kind of a one-to-one mapping on that, where the more developer control on the underlying stack, meaning the developer needs to do stuff to make things work on this app, the less complexity on the underlying infrastructure, right? So with the single container runtime, obviously a developer would need to do a lot to get the application up and running besides just deploying the containers, meaning provide some access and so on, routing, access, et cetera, where the more you go into less developer control, meaning a more solution that does everything for you, there's more complexity on the underlying infrastructure, right? And if we take that and we lay over kind of the VMware Pivotal solutions on that, then vSphere Integrated Container fits in the container instance, where it provides kind of a container host solution. In the middle, we got Pivotal Container Service, which is basically Kubernetes. Kubernetes is a service, and there has a lot more to that, obviously, with Bosch and so on, but it provides Kubernetes services. And on the right side, where we're looking for a solution that does, everything for the developer, and developer only need to just deploy code, that's where you're going to see PCF or PAS on the right side. I hope Pivotal won't get upset. I probably need to fix this slide with the right marketing terms. And there's a place for each one of them, and there's a place for having even both. Where when we talk about PAS or PCF, customized applications that our customers want to develop on their own, they go really well on PAS, on PCF, right? If a customer develops his own applications, especially if it's 12-factor, what we call cloud native, they live very well in PCF. On the other hand, where it comes to deploying off-the-shelf Dockerized data services and so on, Kubernetes is the place to go. So there's a good solution to do with joining both of them, where you deploy customized applications on the left side and data services on the Kubernetes side, and you broker those services using a broker between them. That's kind of an overview. Obviously, I have a much longer talk about this subject, but this is just to show, before I go into demos, kind of what it is that those solutions provide. So I'm going to go into the demos, and within those demos, I'm going to focus on 4 main benefits, big benefits that NSX-T provides today that I'm pretty sure are unmatched in the market. The first thing is heterogeneity. NSX-T supports many different varied workloads, type of workloads, whether it's PIS, Kubernetes, if it's PKS from VMware and Pivotal, or if it's do-it-yourself Kubernetes or OpenShift, they're all supported on NSX-T. Also virtual machines, coming soon, bare metal, cloud, as you guys know, is also going to be supported. vSphere, KVM, all of that is supported in a single unified solution. And why is that important? Because there's never, when we talk about complex applications, there's never just something that's only deployed on, let's say, Kubernetes, or only deployed on PIS, or only deployed on VMs. If I deploy or develop applications on Kubernetes, they may need to access services on virtual machines. Or if I deploy applications and develop them on Pivotal Cloud Foundry, I may have, as you saw on the previous slide, data services running on Kubernetes or on virtual machines or bare metal. So having the ability to have a one solution that is very well integrated with all these type of workloads and is able to provide a seamless experience for the developers by providing networking security for them and the operational tools, it's pretty powerful and unmatched from the variety of workloads supported on NSX-T. The second point that I'm going to focus on is what a good engineer or TPM at VMware taught me, this term called relatability, Yves Fauser, if you guys know. And what he calls relatability, and I kind of adopted this term, is our ability on NSX-T to be able to provide to the DevOps or the security team the ability to see traffic coming from specific logical constructs on the platforms, whether it's Kubernetes or PIS, for example, and to filter based on that. And I'll show that through the demo. It may not be fully make sense right now for anyone that didn't see that before, but consider that you may want to deploy applications on a specific logical tenant or a specific service within Kubernetes. And on the physical network, you can see what's going on. You can see exactly where traffic is coming from, and you don't need to really segment your network to be able to isolate or pinpoint traffic to specific applications. This is very powerful for operations, and you'll see that through my demos. The third point is visibility. The operational tools that NSX provides and all the stuff that we provide as VMware, as you saw that on the first slide, for example, vRealize Log Insight, or the internal tools that NSX-T provides are very powerful, and they're top of the line at the level that our enterprise customers demand. And it's, to be honest, when you work with Kubernetes or you work with PIS and so on, they're pretty lacking on that. It's very hard to be able to monitor and to troubleshoot from the operator view on what's going on, because the containers that have been deployed, sometimes depending on the solution you're working with, if it's not NSX, you may not have an IP on the container, and even if you do, they're ephemeral. They're coming up, they're coming down, they've been killed, they've been treated like cattle. And NSX provides a lot of information and capabilities for operationalizing this on the networking, security, and the DevOps side. So you're going to see that as well. And the last thing that I'm going to start with my first demo is the programmability of NSX-T. It used to be like 3 or 4 years ago, kind of a joke about that we have multiple APIs on multiple products. And VMware really made huge strides towards having robust APIs throughout our solution portfolio. NSX-T is one of the best solutions to be with the robust API at VMware, and I'm going to show you how I can fully automate NSX-T end-to-end from nothing to everything with a single click because the API is so good. All right, finished with the slide. Let's go into demos. So before I go into kind of NSX demo, what I want to do, as I said, I want to show you throughout the session how NSX is so good about API and programmability. So what you see in front of you, and this is open out in the internet, you can reach that. That's a pipeline. If you don't know what a pipeline is used in CI, continuous integration, and continuous development. Basically is a set of actions that you don't deviate from, hence the pipe, and it's been used to either deploy applications or to manage the stack. And this tool specifically, Concourse, it's an open source tool that is used by many of Pivotal customers today. It's a very powerful tool. I mean, I can spend again an hour or two on it, but I'm not gonna. What I'm gonna do is I'm gonna kick off this pipeline, and this pipeline basically goes and deploys all the OVAs that NSX-T requires. It deploys a manager, 3 controllers, the 2 edges, and it ties all of them together. If you ever seen the installation of NSX, there's quite a bit of steps that need to be done. It also goes and then creates all the logical constructs that are required, whether you're deploying PKS on top of it, or Kubernetes, or PCF, or you can set it up as you want. And then we'll go and configure other things like load balancers and SNAP rules, all of that in a single pipeline. So I'm going to kick it off here. And by the end of the session, I will show you a fully deployed NSX-T that I never touched the GUI to deploy. There's nothing right now running on the vSphere side. All right, so to my demos. What I'm going to do is I'm going to demonstrate integration of NSX-T with Kubernetes through PKS. So the Kubernetes cluster is deployed through PKS. And I'm going to show then the integration with PAS. And I'm going to go through this demo in 2 windows. So I'm going to jump back and forth. I'm going to go with PuTTY to do kubectl commands to Kubernetes, for example. And this will basically show you kind of the developer view of things. And I'm going to do also Cloud Foundry CF commands to show you kind of developer integration from the Cloud Foundry side. And I'm going to jump between that and between showing you kind of the NSX side of things. And the NSX side is basically the operator view. And the operator view is not where the developer is. Developer, don't touch this. This is basically NSX console. This is, by the way, the latest 2.2 that just came out 3 days ago. And I'm gonna show you how things happen on NSX, but nothing that I'll do will happen from the NSX side. Everything will be done from the platforms themselves. And this is to show you the heterogeneity of the system. So going back into, I'm gonna start with PKS or Kubernetes. If I do PKS clusters, you can see that I have a Kubernetes cluster that's already deployed that's called PKS1. PKS, if you don't know, that's a VMware and Pivotal and Google solution for an on-premises, fully managed Kubernetes as a service. You run one command and you deploy a Kubernetes cluster that you can then assign to teams to use, and it's fully managed by Bosch. So there's lots of values that we can talk about that again for 2 hours or more. But I'm going to focus my session on NSX, so I'm taking it off from here. And what I'm going to do, I'm going to get into my Kubernetes cluster by doing a command on PKS. So PKS get credentials, PKS1. So I'm basically connecting to my deployed Kubernetes cluster. Obviously, I saved you the agony of waiting for Kubernetes cluster to be deployed. It takes about 20 minutes. So I'm connecting to the Kubernetes cluster. And what I'm going to do is I'm going to start with deploying a namespace. Any of you that don't know what a namespace within Kubernetes is basically a logical tenant. So it's a representation of a logical tenant. So I'm going to deploy a namespace. And you can see when I do get namespaces, you can see that my Kubernetes cluster currently have 4 namespaces. So I'm going to jump off now into NSX. So I don't want to confuse you. I'm going to show you what's happening on the dashboard of NSX. If I look at the routers, and if you don't have background of NSX-T, NSX-T has 2 levels of distributed routers, tier 1 and tier 0s. Tier 1s are tenant routers. And you can see that my tenant routers on my PKS Kubernetes cluster is 4 tier 1 routers that corresponds to the 4 tenants that got deployed. So I'm going to deploy a new one, and that one is called Ujo. That's just an internal code name, actually, for a previous version of NSX. And I created a namespace. So I just ran kubectl, create a namespace from Kubernetes. And if I go back to NSX as an operator, if I click on that, you can see that I have a new tier 1 router created. Clicking into it, you can see that every object in NSX has tags. And tags can be added in many different ways. They can be added automatically, like it happened right now. Basically, all the information got pulled from Kubernetes into the tags. It can be added using API calls and any tool that tags something, or an operator can tag stuff. And all these tags can be used for distributed firewall policies and other things. So in this case, what I'm showing you is basically this is my tenant, and I see information about it. And one thing I can see about this tenant is that it has a specified SNAT IP address. And that's because my Kubernetes cluster is deployed in a NATed environment. And what it allows me to do is that everything that's coming out from my logical tenant on my Kubernetes cluster is going to go out into the physical network with this NAT IP address. That allows your physical network teams basically to go on their firewalls, or if you want to create access lists for which apps can go to my mainframes, or which apps can go to my physical org, or whatever, they can use this SNAT IP address to filter or to set up access list or to monitor the application traffic. And this is what I call relatability. This is very powerful. This is something that it's not easy to achieve, and it provides that capability without the need to. So before that, what we had to do something like that is to create network segments, place the apps on that, and that way we could identify what comes from where. This is everything is logical. Need to go and create segments. It basically allows me to do this identification on my own. If this wasn't a netted environment, we would get a subnet, and we could use just the subnet to identify. So basically, this provides that relatability. So going back to the developer world, I created a tenant. The next thing I want to do is deploy an application. I already mentioned Eve. This is an application that you wrote. This application that's going to be deployed into my new tenant, it's basically a web server, a web front server that has the ability to do port scans. So I can show creation of network policies and how they affect my ability to scan the network. So everything, as you know, or you may not know, on Kubernetes is done through YAML files. So this is my YAML file for my application. It's a replication controller that deploys 4 pods. The application is called NSX demo, and this is the image coming from Docker, and this is the container port. So I'm going to run a command to deploy this app, and I'm going to watch the containers getting created. And you can see the containers are already being deployed, done pretty fast. And you can see that each container got its own IP address. Again, one of the powerful things of NSX is the ability to troubleshoot or pinpoint and actually monitor what's going on. Having a separate IP to each container or pod, to be more accurate, provides us the ability to the operator from NSX or from anywhere else to go and actually see what's happening on an underlying system. So we can actually see the pod's IP addresses here. And if I go back into NSX as an operator, and I'm looking at my switch here where my pods got deployed. So if I look at the switch here called Ujo, that's my tenant switch, and I look at the pods that got created here, and I click on any of these pods. Again, just like previously on the router, you can see that I have a lot of information in the tags, and this information came from the YAML file. So you can see which NCP cluster it's part of, which part of which namespace it's part of, and so on. And you can add annotations and labels within the YAML file, and all of them will go into the tag. And again, you can use those tags to create security policies. So allows me as an operator to see information about the pod. But that's not all. I can look at monitoring of the pod, and I can see exactly which traffic is created on the pod level, on the container. So if it's pod on Kubernetes or AI on PAS, which is a container, but I can actually see how much traffic it's creating from unicast, multicast, broadcast, and so on. Again, for troubleshooting purposes, it's very powerful. And that's not all. We can do quality of service with traffic shaping. We can do port mirroring. So let's assume you have a pod that got vulnerable, and you have a system that basically tagged it as isolated, and you're gonna go and you're gonna set up port mirroring, and you drop everything to a sniffer to go and see what exactly is going on in the pod. This is not a VM, right? This is a pod, and we can actually control all these things and monitor them from NSX-T. Very powerful stuff. All right, going back to my demo, I got my application deployed. What I'm going to do is, because this is Kubernetes, I will need to go and create something called a service. A service on Kubernetes basically is like an internal load balancer that allows a set of pods or microservices to communicate with another set of pods without the need to go and communicate with each pod separately. It's like an internal load balancer, right? In the NSX, and I'll show you, this is my YAML file for the service. And this one specifically is a service type service, right? So it basically will create that internal load balancer. But you can create also an NSX-T, like a service that is type load balancer. And if you do that, not only it will create that service internal load balancing, it will also create L4 load balancing to that service. So assume you're deploying, let's say, a Redis database, right? Multiple containers of Redis. And you set it up as kind load balancer. It will go and create on NSX automatically a VIP for a L4 VIP for that service that on the port for Redis that allows you also to manage those containers using Redis protocol. So NSX kind of service whatever you are deploying on Kubernetes to your liking. So I'm going to create this service here for my application. You can see this one is going to create specifically for that app. And if we look at the service, you can see that it got deployed. And if you look this more deeply, you can see that that service has all the pods information within it, and it provides its cluster AP and so on. It provides the capabilities we needed from it. And if I go now, I'm going to deploy an additional pod that's called pod management, which will allow me to take over it. It's already running here. And I'm going to hijack that. And I'm going to show you how the service works. So basically what I'm going to do, I'm going to go from one pod trying to access the other web front pods using that service. So I'm going to do wget NSX demo. And you can see that I communicate with my pod, which is on the IP 10.4.11.5. And if I do again, it goes to another pod. So you can see that I'm doing internal balancing going from pod to pod. Should go to the next one. From pod to pod using that service. And the last thing we need to do to allow access to our application, again, this is all Kubernetes stuff. The developers or the operators need to do that anyway, is to create ingress spec. NSX in the previous version deployed a load balancer for each Kubernetes cluster you deployed, or each Kubernetes cluster you deployed on NSX, whether it's from PKS or not, but with PKS the integration is a bit better. And you can see that load balancer here for my Kubernetes cluster. In the new version that just came out lately, you can actually combine Kubernetes clusters on the same load balancer if you want to. So you don't have to deploy multiple load balancers, which makes things more flexible, and you can specify that in the YAML file, basically if you want to attach to an existing load balancer or not. But here in this case, I deployed a load balancer automatically when I created the Kubernetes cluster. But if I go to server pools, you can see that I have server pools for PIS stuff, nothing here to allow me access to my app. So as a developer, the developer needs to go here and create what's called an ingress spec. So if I look at my ingress YAML file, you can see that it says this is a kind ingress. It basically, this is the host name that's going to be accessible for this ingress. This is L7 load balancing, obviously, but it won't deploy any new NGINX. It basically will attach to NSX load balancer. and this is the port it's going to mean, and this is the NSX. This is the sorry, the service name is going to service, right? So I'm going to deploy that, and I'm going to see the ingress controller, and I'm going to be able to ping my application. So if I go back to NSX again to the operator view, and I look on my server pools and I refresh this, you can see that the new server pool got created, where it is here, and you can see that already there's 4 members within the pool that are my pods. So it automatically populates with the service with the pods that are part of the service, so they're accessible. I'm going to go to my application here. I already have it in DNS, and this is my web front server. If I click through again, you can see that I'm attaching to different pods every time I go into. Now, here's the cool part, right? Or actually the bad part is that if I go and do a port scan on the network, and this pod can do port scanning. If I do a port scan, you will be able to see that going east-west, I can see all the pods that are around me. So you can see the other pods, and even the one that I had with the hijack to show the service, which has SSH open. So I don't know if you guys are aware, containers are highly unsecure. It's easy to hijack. So if I can go east-west and port scan, I can definitely go in, and if I take if I take control of one pod, I can get into the others. So what do? Does a developer needs to go and ask the network team to go and create security policies? No. Again, just like we did before, the developer did not need to go and ask for load balancing, and did not need to go and ask for services access to his application. It does just need to have a security policy baked into the YAML files, or if you do it from an operator view, you can do it on you can do it in the pipelines. If you deploy it with pipelines, you can inject security policies in pipeline. Doesn't matter how you do that. What I'm going to do now is I'm going to have 2 YAML files. The first one creates a policy that set up default deny, and this one specifically does it on my namespace, which basically says block everything. So nothing can access nothing, right? So I'm going to do that right now. And jump too fast. But if I look back on my application, you can see that if I try to go and access my app right now, it's gonna hang. I can't access anything. So what I'm gonna do is I'm gonna allow access to my load balancer from north-south to be able to access my app. And all the YAML files that I showed you during this session, all the YAML files can be combined to few YAML files, or even one, right? If you want to, as the manifest. But this is just to show you all the different integrations. So now I got access back to my app. Again, I can see all the containers. But now if I go in and do port scan around my network, I won't be able to see anything. And this is because of the distributed firewall capabilities. If you know NSX-V, very similar on NSX-T, we got distributed firewall. So if I go now here to the firewall, you will see that there's a new rule that got created, and this rule basically allow access to my application containers. You can see that this has a nice icon here, which is basically a security group, and these are the members, right? Security groups is basically dynamic groups that allow me to create policies around. Again, I can use tags for it. In this case, basically, Kubernetes just went through an API call and created that, and the security group got created using through the CNI. It's a bit. I'm not going to go into kind of the mechanism right now. Just want to show you how it works. But basically, when I ran the security policy, NSX-T accommodated that using security groups. So now I can access my apps, but nothing can communicate around it. So if you look here, I got my section that corresponds to the namespace, and you can see the rule here is basically any drop. So anything on this namespace is dropped besides access to my app from the load balancer. So what did you see here? You saw me doing everything as a developer to have my application running with security policies, with load balancing, with a service, without the need to go and ask the operators or the NSX operators, whoever, to allow me access to my app or to create those things. It all happened seamlessly as developer needs it. And now I'm going to go into kind of the heterogeneity part of it, because what I want to show you now is the same integration on the same NSX-T, but using PCF. And this will also apply to other platforms that can work on NSX. So if I do CF commands, and you can see I will communicate with my Cloud Foundry environment, same NSX, same place. And I'm going to do something. I'm going to create an organization on PCF. Organization is very similar to namespaces in Kubernetes. It's a logical tenant, so I'm going to create an org. Let's call it vBrownBag, just for our sake. I'm going to target that. And I'm going to create something called a space. Reason is in Cloud Foundry, there's multiple levels of tenancy. So in this case, I'm going to create a space called vBrownBag, and I'm going to target that as well. Again, this is a logical tenant, just like a namespace. So, all right. And what I'm going to do is I'm going to go into an app I have, and this app is basically built out of two layers, two tiers, a front end and a back end, again, to demonstrate the ability to create security policies on NSX and how we manage those. So I'm going to go into my app code. Again, this is Cloud Foundry. And if you remember when I started, I explained kind of the difference between the level of abstractions. Cloud Foundry does a lot of the things that you saw me do on Kubernetes. I don't need to create an ingress controller or service. It all happens to me automatically because the system kind of creates all these things beforehand, some of them, and some of them are created automatically, like creating the pods or the AIs. In our case, I'm going to just go into my code. Sorry. That was source, example, apps, cats, and front end. So I'm going to deploy the first app. The only thing I need to do is just one command called cf push. It identifies what it does. Cf push, and call it vBrownBag frontend. And what it does now, it will go and upload the code, and will what PCF or Cloud Foundry actually does. It creates the container, it stages it, it tests it, and then it deploys it to Cloud Foundry. And then it keeps the layers somewhere in the blob store, so that if you ever need to change some layers in the container, like let's say you want to change the runtime for Java, you just provide that to Cloud Foundry, and it will go and grab all the layers of all your containers from the blob store, and will recreate all your containers in a seamless manner. This is what PaaS does in opposite to a CAS, which is Kubernetes. And it's a use case, kind of different use cases for different customers. But my application got deployed, and I already have a URL to access. I don't need to create anything. So I'm going to access this URL here. I'm going to go here. I'm going to access this URL. And my application is up and running. This is the front end. I'm going to deploy a backend now. So I'm going to go into the backend. I'm going to do cf push vBrownBag backend. While it's deployed, let me show you some things what happened on NSX. So going into NSX here, and I'm going to the routing. You remember when I created a namespace on Kubernetes and it created a router for me? The same goes for Cloud Foundry. You can see that on Cloud Foundry, I got the PCF vBrownBag router here. And if I go into that and I look at the tags here, you can see that I have everything I want to know about it. And of course, the SNAT IP address that I will know how to identify traffic coming from a specific logical tenant going out to the physical network. And if anyone knows Cloud Foundry, previously what you had to do to achieve this is something called isolation segments. I'm not a big fan of isolation segments. This kind of eliminates the need to use them, because now we can actually isolate traffic from applications on a logical level rather than segment level. So this happened. If I go to switching, I also have a new switch deployed for my new tenant. So if I refresh this, go into switches actually, and refresh this, you can see I have a switch here. And if I look on the switch, you can see my containers. If I click on any of these containers, you can see this is my application. I can see all the information coming from the application manifest. So what org it is and so on, all of this comes as tags. These tags are usable for me, again, for access lists, for security policies, for monitoring, and so on. And I can do everything I did on a Kubernetes pod, I can do on a Cloud Foundry AI or container, like monitor, quality of service, and so on. All those capabilities apply for both, and also for virtual machines and coming down the line bare metal, right? All of that will be available for stuff. So going back to my application, this is my app here. This is my backend app. I'm going to access my backend app here. So I got my front end, I got my backend. Consider those as not as two separate apps. Consider them as two microservices that are part of a single application. They may look as two applications, but they need to communicate with each other. You can see, again, each container has its own IP address, and this one specifically tells me I'm using this IP address on this port. Now what I'm going to do is I'm going to try and access from the front end to the back end on this port. Now if I go here and I do that on port 7007, for example, from the ports it showed me, it won't be able to. The integration we did with Cloud Foundry is slightly different from an operational perspective. You see the dog says I don't know what to do, I can't access the backend. What we did is when you deploy an organization on NSX-T from Cloud Foundry, it automatically it allows access north-south. It automatically blocks all east-west. So you can see that if I look on my tenant here, oh, I need to refresh this. If you look at my tenant, you'll see that it has already automatically a rule for my tenant for vBrownBag. And these rules say allow access to my application from outside, but drop everything else, and that's why I get the dog. So what does, again, a developer needs to do to be able to allow access to between these microservices? It doesn't need to go to the security team, as you can imagine. I just need to run one command, or obviously the developers don't run these commands, they just deploy pipelines, they deploy the code and the pipelines runs these commands. So the command would be run. That's going to be cf-add network policy. It's going to be the application name. Developers don't know IPs or stuff like that. They need the application name. So it was vBrownBag front end needs to access a destination app called vBrownBag backend, and on a protocol of TCP and port 700.
Niran, careful with destination. You're missing a T.
Oh, thank you very much, my friend. There you go. Hit enter. It goes through this policy. It basically created it. I go back to my app here. I go back to my front end. I do back and forth and ask again, and I get a cat. You like that, Ariel? Cats?
A cat.
Yeah. So I can now basically show that my front-end microservices can access my back-end microservices. And if I look at NSX here on the firewall, I'm going to refresh this page. You'll see that the new rule just got created, and the new rule basically says allow this security policy where my containers are to these containers from the back-end on this port 7007. And if I go into the group, you'll see that it has one container right now. If I scale up those applications, the groups automatically inherit the groups automatically gets populated with the new containers, and obviously they inherit the security policy. So what you saw here is a very similar experience, a seamless experience for the developer, whether it was PIS or Kubernetes, where they didn't need to go to the security or networking team to create anything. Everything was done for them on the application level, Well, the operations team that manages NSX, whether the DevOps team or the security team or whatever, they have all the control of the system, of what's going on, and they can see everything that's going on. I didn't drill down even a slight bit into the operational tools here, so I'm gonna kind of show you cool stuff that's going on here, but just a bit because we are short on time. NSX has really nice operational tools. One of them that I really like is called TraceFlow. And TraceFlow allows you, basically, you specify, hey, something doesn't work. I want to check to see why one container cannot talk with another container on a specific port, or one container cannot speak with that virtual machine on a different port. It will basically inject a packet and will SYN packet and will show you the result of why it failed. So if I do, for example, the vBrownBag front end wants to access vBrownBag backend, where is it? vBrownBag backend here, and let's say I want to test on TCP, and I want to check what's going on, why it doesn't work on, let's say, 7008, and I trace it. It will show me all the steps a packet went through or where it failed. It can also show you physical stuff if it's integrated. My lab doesn't have it. I'm running a nested environment here. But basically, it shows me that it was dropped, and it shows exactly which firewall it got dropped on, which is 2124. So if I go to the firewall and I'm looking for rule 2124, you'll see that it's right here, 2124, which is any drop on PCF. If I go back to the tool and let's do edit and just change the port to 7007 and trace, you'll see that it will be able to, and will show me exactly what path it took, and exactly which step it went through. So it gives me a map of the path the packet took from one side to the other, and the firewalls route it went through. This is just one tool. If you combine NSX-T with vRealize login site, it's so powerful. You can see all the information that's going on here, and you can actually create a really nice mapping of ports. So you can basically deploy an application on NSX-T, containerized or not, and you can actually drop everything to vRealize login site, and it will tell you exactly which communications are being created between those, so that you can create your security policy without hurting yourself, because as you probably know, we don't know usually what the ports that our application require, even if we developed it. I'm going to pause here. Oh, before I pause, I'm going to finish my first demo, which was the pipeline. And if you look at the pipeline here, oh, it failed on me. All right.
It wouldn't be vBrownBag if everything went perfect.
Well, now you know I'm not bullshitting you. It's a live environment, and basically I put something wrong in my parameter file, so it failed to find my vCenter, But if it would go through, it's embarrassing, but it would go and configure everything. What it did do is deploy everything here from an NSX perspective. So if I go to NSX, it didn't deploy the logical stuff, but it did deploy all the physical integration. So if I go to NSX here, you'll see that, and I can fix this pipeline pretty easy, but we don't have enough time. But you'll see that I will get now the end user license agreement, which basically shows that I did not touch the GUI even once, and everything was done with the API. So if I go here, you will be able to see that NSX deployed a bunch of stuff, the controllers, the edges, and connected them together. It just didn't deploy all the routers that was supposed to create. So those weren't created, but just one of them. All right, I'm going to pause here, and I'm going to open this up for questions. Any questions on the chat or Twitter?
I mean, most people have been like, "This is so freaking awesome." No real questions, just comments.
Yeah, it's a lot of the comments we're getting are how amazing it is and how great the demos were flowing. And
Well, until one failed, right?
well,
Yeah.
I was going to
But
be
that's just
concerned if it didn't fail. So
exactly that's more credibility.
yeah.
So, Niran, is there a way to do something where you can react automatically to a failure?
What kind of failure are you referring to?
Say some of the containers fail. Say something happens to some of the services you're running. Obviously, everything's been running behind a load balancer, but can you react and recreate, or
Oh, so yeah,
and
are
rebuild?
you asking about Kubernetes or about Pivotal Cloud Foundry? Each one takes care of it differently. Though when we talk about PKS, which is a VMware and Pivotal's Kubernetes distribution, that one actually comes really close because of the BOSH, and now it's going to support multi-AZ and stuff like that. It becomes more closer to PCF. But basically, in those cases, what you do is it deploys workers in different racks. And if one rack fails, the applications continue to run in another one. And if you deploy multi-site, you usually put a global load balancer in front of them, and you push traffic to the site that's alive.
Okay, and how are you monitoring all this to make sure that these things, is that just the workers that are handling it all, in the background the whole time, or?
Yeah. So with PKS, BOSH is a really powerful engine, which basically sometimes people compare BOSH into a configuration manager like Chef or Ansible or Puppet. Well, BOSH is quite different. BOSH does not look to fix a desired state or a drift from a desired state. BOSH basically kills a machine that went into undesired state, or if it's not responding, or if it's dead, and recreates it if it's not there. It also monitors for the health of the virtual machines, and virtual machine obviously run the pods. So if you have any problem, BOSH will go and kill it and will redeploy it. So BOSH provides a lot of that capability for our services, which is PIS and PKS. If you're talking only straight up Kubernetes, when I deployed, you remember the application, I deployed something called our application controller. That one basically monitors to see if the pods are alive. If one of them is not, we'll redeploy another one. But that's on the pod level. It's not on the infrastructure side.
Okay, thanks. That's all for me.
Right. I
Anything else?
know I put a lot of information in this session. So if anyone has any more questions after, or you see this on YouTube or whatever, you feel free to contact me on Twitter. My Twitter handle is Niran. I would love to assist or direct you to the right information.
That's great. Thanks for putting that out there. I'll make sure that that information is in the show notes, and I'll try to get some of those goes in there too, and I'll get it up at ASAP. If we've got a lot of people wanting to unpack and to be able to go back and watch this again. So great job.
Thank you very much. Thank you guys for the opportunity and to show what we do here at VMware.
This is amazing. I never would have even been able to dream all this was going on. It's just so much different things happening coming out of the company. This is great.
I'll tell you, and I've been doing VMware since 2000, right? So I've been working and selling and implementing vSphere in 2007, 2005, and 2008. And what I get when I show this stuff to DevOps guys, or security teams, the folks that are not usually where VMware's go to market, I show this to them and I get the same faces I used to get on vSphere, which is wow. And if you can deliver 10% of what you're showing me here, I'm buying this, right? And we deliver 100%. It's so much feels like vSphere in the old days that it's so much fun.
That's awesome. Yeah, it's crazy. With that, I guess we'll end tonight's show. So thank you very much. And If you have any questions, contact us. Use hashtag vBrownBag, and we'll do follow up later. Thanks.